Hello engineering and welcome to the third lecture in our civil engineering math set where we're going to talk about some concrete mixing, right? Dun dun dun. You also did that concrete reading, right? So this is where it all starts to come together, right? So in concrete, like it says in that reading that you did, right? Concrete is made up of cement, which is one component, fine aggregate, which is typically sand, and coarse aggregate, which is rock, right? Sometimes it can be like teeny tiny rocks, a little bit larger rocks. Sometimes it's a mix, right? But it's called the coarse aggregate. And water, right? So basically we want to determine the weights of cement, fine aggregate, and coarse aggregate. So we're looking at weights. And water to make two concrete cylinders using a 1:2:3 mix ratio. Now, when we say 1:2:3 mix ratio, the mix ratio is cement to fine aggregate to coarse aggregate, right? That's what that means in a mass-based ratio, right? And it says that the cylindrical molds are 6 inches tall and 3 inches in diameter. And we're going to assume that this is normal concrete with a unit weight of 145 pounds per feet cubed. Use a water to cement ratio of 0.55 and a waste factor of 1.05. Show all work. So the goal is to determine the weights, right? So we need to know the mass of cement and fine aggregate and coarse aggregate and water. That's what we want to know. These are our questions, right? We know that we need to make two cylinders. And what else do we know? We know that it's a 1:2:3 ratio of cement to fine aggregate to coarse aggregate. We also know that for my cylinder, right, the diameter equals 3 inches and my height equals 6 inches. We also happen to know that our water to cement ratio, when we're ready for it, is going to be 0.55, and that my waste factor is 1.05, right? Another way to say that is that 5% is extra, is how much extra we should budget, right? Because obviously with most things in life, right, we don't always get the exact amount and we should always budget a little bit extra, right? Stuff sticks to the place where you mix it, right? You lose little bits here and there, right? You make a mistake when you get it started, right? All these things are places, all these are places where we lose stuff, right? So we need to plan for that. So this is what we know. So let's figure out where to start, right? And I promise that as we work through this, right, you're going to see that all of this is math that you know how to do, which is like amazing, right? Which is the beauty of dimensional analysis, right? So even though a problem looks hard and seems to be talking about stuff that you haven't a clue about, it's okay as long as we understand units. All right. Let's go ahead and make all of our information a little bit smaller over here, right? So now let's go ahead and get started with our problem solving. So step one, what seems like it would be a good step one? Right, let's go ahead and calculate our total volume needed. All right, so in order to get my volume, I have a cylinder, right? And so the volume of a cylinder is what? Right, pi r squared h. So we can go ahead and get started with that, right? So this is going to equal pi times 1.5 inches squared times 6 inches, right? And I'm going to take this whole thing and multiply it by 2 because I have two cylinders, right? This is going to give me a volume total of 84.82 inches cubed. Because again, I took inches times inches again, times inches one more time, and that's going to give me inches cubed. So that is the total volume that I need to consider. Step two, now we're going to wrap in that waste factor, right? So step two, my waste factor is 1.05%, right? Which basically means that I need to budget an extra 5%, right? Can someone tell me, can you think about what are some of the ways that we can do that? Right, one of the easiest ways to do that, right, would be just to take 84.82 inches cubed, which is the exact volume that we need, right, and take that and multiply it by 1.05, right? And that's going to give us 89.06 inches cubed, right? So what that's doing is that's giving us an extra 5% volume to work with. Yes, does that make sense, right? An extra 5% volume to work with, right? Just in case we make a mistake or who knows, we lose a little bit. All right, let's go put this over here and let's look at our next step. All right, so next step, so we've got our volume. We did our necessary volume. Then we factored in our waste to get our volume total with the waste factor built in, right? Now, what we're going to do is we're going to take our, where do I want to start this? We're going to take our 89.06 inches cubed and we are going to use our, oh, I forgot to write down our unit weight, right? Unit weight is equal to 145 pounds per feet cubed, right? And again, every time we see that, we should think, 145 pounds are equal to 1 foot cubed, right? It's a relationship. And it's like density, right? So in science, right? So in science, like your chemistry, biology, things like that, we talk about density, right? Density is mass per unit volume. In other fields of science, right, they talk about things that are also mass to volume ratios, right? Sometimes with different names, right? In civil engineering, when they talk about concrete, right, the standard term is unit weight and it's in pounds per feet cubed, right? So 89.06 inches cubed is what we have, right? And we need to turn that into something where we can use this conversion factor, right? Because this converts between weight and volume, right? I have what's this right here? Right, I have a volume and I need to get to a weight. So I need to turn my inches cubed into, correct, feet cubed, right? And so the simplest way to do that, right? Well, actually, I guess there are two ways, right? The really simplest way, if we had thought about it beforehand, would be here, right? Here, we could have turned our radius and our height into feet, and that would have given it to us in the beginning, right? And that would be the easiest thing to do. Now, we forgot to do that. So what we're going to do is we're going to do a different way, right? Do I know the relationship between inches and feet? Yes, I do, right? I know that 12 inches are equal to 1 foot, right? But our volume is a cubed unit, right? So one-dimensional unit isn't going to work. So what that means is I can just cube my parts, right? Which means that actually 12 times 12 times 12, which is 1,728 inches cubed, are equal to 1 foot cubed, because 1 times 1 times 1 is still 1, right? Does that make sense? If that doesn't make sense, right, then this is just where we have to be a little bit more attentive, right? And we can do our conversion over here, right? We could even go back and convert our inches into feet, and get our volume in feet, and that would be just fine, and we'd end up in the exact same place, okay? And my inches cubed cancel, and now I can take advantage of my 1 foot cubed is equal to 145 pounds. So when I do that, I get that my answer is 7.474 pounds. And that is the total mass of, because we should label things, right? Especially in a multi-step problem. This is the mass of concrete that we need. Yes, does that make sense, right? So step 1 is I found the total volume. Step 2, I factored in the waste factor, so an extra 5%. Step 3, I took my volume and I converted it to a mass. Yes? All right. So that was step 3. Now let's see what's next. So step 4, right? Now I know my total mass that I need, right? I also know that I need a 1 to 2 to 3 ratio, right, of cement, fine aggregate, coarse aggregate, right? Different types of cement have different ratios depending on what the needs are for that concrete, right? Like what do you need it to do? Where do you need that concrete to be? That sort of thing, right? You're not expected to know what they all are at this point, right? We're just learning how to make basic concrete, right? So those are our ratios. What that means, right, is that there are a total of 6 parts. Yes, does that make sense, right? In that we have 1 part cement, 2 parts fine aggregate, 3 parts coarse aggregate, which means there are a total of 6 parts, right? Which means that I can take my 7.474 pounds and divide that by 6, right? 6 parts. And that's going to give me basically what? What's that going to give me? Right, the pounds per part. So 1.25 is my number of pounds per part. Yes, does that make sense, right? Which means that my concrete is, or my cement is going to be 1.25 pounds, right? That means my fine aggregate is going to be 2 times that. So that would be 2.50 pounds. And then my fine aggregate, my coarse aggregate, would be 3 times, so 3.75 pounds coarse aggregate. Yes? All right. I forgot to label it. That's fine. All right. So this would be step 4. All right, and let's see, where are we? What's next? All right, next we got to do the water, right? So we have found our cement, our fine aggregate, and our coarse aggregate. Next up, we need to do water. And I know that my water to cement ratio is 0.55, right? And so when I say my water to cement ratio, right? So water to cement has to equal 0.55, right? And since they're both in pounds, 0.55 is unitless, right? Does that make sense? So let's scooch this up a bit. Now let's put in our information, right? My cement right here is 1.25. So I've got water on top of 1.25 is equal to 0.55. So then I would just solve for my water, right? And so my water is going to equal 0.688 pounds. So there's that, right? So then if I look at all of my pieces, right, I have solved for my cement, fine aggregate, coarse aggregate, and my total amount of water. What that means is I mix all those things together and I will have made a 1 to 2 to 3 mix ratio for my 2 concrete cylinders with a waste factor of 5%, meaning that I should be able to fill and pack my concrete cylinders well and hopefully still have a little bit left at the end. Yes? And you'll see here, while the concepts are new and different, right, the ideas, right, the math that we did is stuff that you already know how to do, right? Which is awesome, I think. It's super cool. All right. Thank you for listening. Be good, and no worries. We will do some more practice together. Thank you for listening. Be good, and I'll see you soon. Bye.